Consider the function f of x is 1 over x, which is graphed twice below. We want to shade two different regions, each with area exactly natural log of 2. Well, we know that the integral from a to b of 1 over x dx would be log x from a to b. Now that would be, let's just move over here, ln b take away ln a, which is ln b over a. So if we want that to be ln 2, it follows that b has to be twice a. So, for example, we could shade going from 1 to 2, and therefore our b is twice a. Or we could shade going from 2 to 4, and the other one that we can easily shade on here is 3 to 6. We're given that the integral from a to b, 1 over x dx is ln 3. What's the relationship between a and b? Well, it's kind of what we did earlier on, in that we know that the integral from a to b of 1 over x dx is going to be ln x from a to b, which is ln b take away ln a, which is of course ln b over a. And so for this to be 3, we're going to need that b is equal to 3 times a. Okay. So we've got another graph shown here. By considering the areas of rectangles shown, demonstrate and explain why the integral of 1 over x from 3 to 2 is between 11/30 and 9/20. Now, let's just first think about the area from 2 to 3. That's going to be the area that I'm currently shading in yellow, like this. If we use a series of inscribed rectangles, in this case, they're going to be right rectangles. So the height of them is the measurement at the right-hand end of the rectangle. So if I use those two rectangles, clearly the area of those is going to be less. Now we can see they've both got a width of a half. And so we can see that the area there, so the height of the first one is 2/5, is 2/5 times a half. And the second rectangle, its height is 1/3. And the width, of course, is a half again. So that is going to be, 2's cancel here, 1/5, add 1/6, which gives us a common denominator of 30, and that will be 6/30, add 5/30, which is 11/30. On the other hand, if we used circumscribed rectangles, and these ones with the height at the left, so we'd now be using these two rectangles, and clearly we can see there's area like here and here, which is above the curve. And so the area of those two rectangles is greater. So let's look at those ones. The first one has a height of a half. So it's going to be a half times a half. And the second one is actually this one again. And so we know that that one already is 1/5. And therefore we have a quarter add a fifth, common denominator of 20, multiply this one by 5, multiply this one by 4, and so that is going to be 9/20. And so we can see why this is the case. The true area is trapped between those areas formed by the rectangles. Hence show that the ln of 1.5 is that. Well, all we need to do now is evaluate the integral. 2 to 3, 1/x dx. That is going to be ln x from 2 to 3, which is ln 3, take away ln 2, which is ln 3/2, which of course is ln 1.5.